so I was talking about the CNCG Ahmedabad project tour idea, where we ask maintainers of various CNCF projects to come up over here and share about the project, the idea behind the project, how it is being, how to contribute if there are opportunities to do, which I'm sure there are a lot. And since I think this is our 9th episode, the last one was about Argo family. We had a lot of we had Costis, who shared us about the Argo family and how wide it is, and it's not just Argo CD, which is nice. We have had Cilium, eBPF, we have had Knative, Kyverno, and I think Chaos Engineering, and there's a whole list of it. I'll be sharing the link to that project tour, which is in, I think it is already in the chat, but we'll do it later on. So for today, it is a another very important project, and I think me as a software engineer who has to come up with on calls and find lags and issues in the project, in the product that you are already shipped to deployment, and that's where the telemetry angle comes in. You need some information, you need some benchmarking and all those things. So that's where the OpenTelemetry thing comes in, and I think we are very grateful to have Adriana, who is also a maintainer to the project, come up and share her insights about the project and enlighten us. So will not take much of a time, and Adriana, if you can start, introduce yourself, or maybe give some highlights of what you do, because I think I see a lot of things on your profile, so let's have you only speak about it.
Yeah, for sure. I'm gonna share my screen. Hang on one sec. Of course, I have to open my system settings to share my screen. Hopefully that worked. One sec. Oh, lordy. Here we go. There we go. Okay. Hi, everyone. Thank you, Avinash and Shivla, for having me and for inviting me on this CNCF Projects Tour to talk about OpenTelemetry. So, brief intro of my of what I do. My name is Adriana Villela, and I am a CNCF ambassador. I am one of the maintainers of the OTel End User SIG. I am also a serial blogger, so my favorite way to share information is through blogging. I also have a podcast called the Geeking Out Podcast. I have been a CNCF ambassador since 2023. I joined the OpenTelemetry world in 2022. And I'm excited to give everyone an overview of what OpenTelemetry is all about. So here we go. So first off, we're going to start off with OpenTelemetry overview. But first, I'm going to give you a definition of observability, which is honestly like one of my favorite definitions of observability. And it comes from my good friend, Hazel Weekly, in which she says observability is the process through which one develops the ability to ask meaningful questions, get useful answers, and act effectively on what you learn. And really, I think the thing that attracted me to observability is the fact that if you've been in software long enough, trying to understand why things are doing, why things are working the way they are, especially when you have a bug in prod, is excruciating and stressful. And observability gives us this promise of giving us the better insights into our systems so that we understand what's going on. Now, on to OpenTelemetry. So OpenTelemetry is a CNCF project. It is vendor neutral, and it came about from the merger of Open Census, which came from Google Open Source World, and Open Tracing, which was a CNCF project. It was born in 2019 when these two projects merged, and as a result, both projects are now archived. And the thing that I think is so cool about OpenTelemetry is the fact that it has the support of and backing of the major observability vendors out there, which I think is incredible, because it means that, you know, rather than just having one vendor dictating how we're doing observability, how we're emitting telemetry signals, like we all get to come together and share in this and build this. And you know, I work in the OTel End User SIG with many folks who are effectively competitors, but it doesn't feel like we're competitors because we're all working towards the same goal. And fun fact, OpenTelemetry has, I think, the second highest project velocity in the CNCF, second to Kubernetes, which is kind of a big deal considering we've only been around since 2019. So super cool. Now, OpenTelemetry is made up of signals, and a signal is anything that gives you data. And there are three main OpenTelemetry signals. There are traces, logs, and metrics, and more recently, profiling has been added to the mix. I'm going to cover just the base ones, traces, logs, and metrics. But yeah, we have baggage, profiling, and events. Now, in terms of OpenTelemetry components, there are a few core OTel components that you should be aware of. First of all, it's the OpenTelemetry specification. And the specification is important because it, you can think of it as basically like, it tells us, it provides us that standard definition of what the telemetry data looks like and describes head instrument code. So it ensures that users have a similar experience regardless of what language they're using. Next, we have the OpenTelemetry data model, which defines the fields for each telemetry signal and how they interact with each other. And as I said, the signals include traces, logs, metrics, baggage, profiling. Next, we have the OpenTelemetry API, or Application Programming Interface, and it defines the methods for instrumenting the applications, and it serves as the entry point for instrumentation. And the thing about the API, you can look at it this way. So, you know, if the OpenTelemetry specification semantic conventions tell us, you know, those standard labels for our telemetry, the API is the what, and each language supported by OpenTelemetry has its own API implementation. So there's going to be a Python API and a Java API. And then we have the SDK. Now, the SDK stands for Software Development Kit, and it is an implementation of the API. So where the API is the what, the SDK is the how. So how is our telemetry generated and correlated? And again, each language supported by OpenTelemetry has its own SDK. Now, the cool thing that I love about OpenTelemetry is basically there's like the standard upstream OpenTelemetry SDK, but like, for example, each vendor could come up with their own SDK, or you can write your own SDK if you want. As long as it implements the OpenTelemetry API, you can swap these out. So then it's not going to break your code when you're instrumenting it, because like I said, as long as you're implementing the API. The other cool thing about how it's designed is, you know, if you're not ready to commit to, you know, what SDK you want to use, that's not a problem, because there is basically the API has a minimal implementation of the SDK. So that means that when you're instrumenting your code, it's not going to break your code, because even though you haven't committed to to which SDK you want to use, because it has that minimal implementation. Now, the only thing it means, if you until you select a proper SDK, is that it won't send any data to your observability backend. So fun little fact there. We also have the OpenTelemetry collector, and I'll get into more details on the OTel collector shortly, but basically it's a vendor neutral binary that's used to ingest, transform, and export data into one or more observability backends. And honestly, it's one of my favorite parts of OpenTelemetry. We have the OpenTelemetry protocol as well, or OTLP. And if you think of, like going back, our semantic conventions are our standard labels. The API is the what, the SDK is the how. The OpenTelemetry protocol is the method in which we are transporting that data over and sending it to our observability backends. So you can think of like, we use JSON to send data over. You can think of like OTLP isn't JSON, but you can think of it in that similar fashion. So it's like your data format for transporting your OTel data. So now that we have that basic overview, let us talk about quickly. I will talk about the OTel signals, but first I'm going to give you a brief overview of instrumentation. So OpenTelemetry basically supports two types of instrumentation. We have and instrumentation is the process of adding code to software to generate telemetry signals. So we have two ways. One is code-based instrumentation, and then we have zero code instrumentation or automatic instrumentation. And basically, when it comes to zero code instrumentation or automatic instrumentation, it is, as the name implies, which is we are not adding any code to our existing application code to instrument our code. So it's kind of done for us. Think of it as like a wrapper that injects the instrumentation for you. And then we have code-based instrumentation, in which you have to go into your code and manually add in the traces, logs, and metrics into your code. So with keeping that in mind, let's look at some of the basic concepts on the OpenTelemetry signals. So first off, we have distributed tracing. And this is a definition from the Observability Engineering book, where distributed tracing is a method of tracking the progression of a single request called a trace, as it is handled by various services that make up an application. So what does that mean? Well, basically, the idea behind the trace is that it gives us essentially the relationships between not only among our services, but also within our services. So you can think of it as like allowing you to follow the breadcrumbs of what happens. Like, say, you're on an online shopping site and you are buying shoes, and so what happens? A trace will describe basically the things that happen from the moment you select your favorite pair of shoes and hit the add to cart button. So traces will basically describe that for us. So it helps us understand our system interdependencies and provides us that nice holistic view of our systems. And they are first-class citizens of observability because they give us that like high-level big picture of what is happening. And this is basically an example of a distributed trace as visualized in Jaeger, which is another open source project of the CNCF. Now, traces themselves are made up of smaller components called spans, and a span is the basic building block of the trace. So each of these bars here that we see in this diagram represent a span. And so we have a span, we have our overall span, which is called the root span. So a root span is basically a span without a parent. So that's this guy here. And then the child spans are the other ones. So we have our PyOTel client, PyOTel server, and then within PyOTel server, you can see that we have two other child spans. Now, the question is, the thing about spans is that unless they're correlated, they're stitched together, we don't have that full picture, right? So like individual spans are kind of useless to us unless we know how they're all interrelated. So the way that we do that is basically through context. And context, again, to borrow a definition from my friend Hazel Weekly, context is the glue that turns a pack of data into a unified trace. So for example, here we have service A and service B. Service A has send requests and get, and service B has roll dice and do roll. How do we relate those, basically those traces? We do, first of all, we have the context propagation within our services. So we basically create that correlation between send requests and get in service A. And then we have that correlation between roll dice and do roll in service B. But also we care about how we have that correlation across services. So then we also have that correlation between service A and service B. So once get gets called, then get calls roll dice. And so we can see how that service request flows through our traces. So that gives you an idea of the correlation of traces in a nutshell. Now, as I mentioned, we have our spans, and as we can see here, actually, even going back to this diagram here, these children, so the way that we link our spans together, so we have the context propagation, we have the span ID, and then each span also has a parent ID, so that we know that a child span belongs to another parent, with the exception of our root span, which has no parent. All right. So this shows, again, just what I was showing earlier with regards to the correlation of our spans. And the other important part, because as I said, the spans are made up of traces. Traces are made up of spans, rather. The thing that all of these spans have in common, on top of, not just having the parent-child relationships of the spans, the way that we identify these spans as belonging to the same trace is that they all have the same trace ID. And then here, again, this shows that within service B, roll dice and do roll have the same parent ID. Now, the next concept that I want to cover is logs. And a log basically is a structured or unstructured time-stamped message that's emitted by a service. And I think that's probably one of the signals that we're most familiar with as developers, because, all those times when you're debugging your code, I don't know about you, but whenever I'm debugging my code, I love to put log messages of like, are you here? Obviously, eventually when our code goes to production, we have more significant log messages that provide us a little bit more information. But the main gist is logs basically tell us about a thing that happened at a certain point in time. Now, that's great, but inherently logs lack context. And so in order to make them more useful to us where possible, we should try to correlate them to traces. So then in the greater scheme of things, we have our traces that tell us like, hey, how are these services and method calls, etc., interrelated? But then the logs tell us, hey, within this service, this thing happened, and this other thing happened, and this other thing happened. So here's an example. This is from the OpenTelemetry demo app. In the payment service, we have a log message here that shows up, and this is a structured data format, and we do prefer our logs to be structured, especially for OpenTelemetry, where we have information like the log level, and we have the timestamp and all this other information, and of course our log message. So That gives you a brief overview of logs. And then finally, we have metrics. And metrics essentially are measurements that are collected at runtime to provide insights into the performance and health of the system. And I would say of the three signals, that's probably the second most well-known signal, I think, to developers, certainly to to operators, for sure. And the thing with metrics is that they're great for showing trends in your data, but they can only offer us a high-level summary of the data because you can't really use them to drill down to get more information. So as a result, metrics don't provide us that depth needed to identify specific root causes, anomalies, and subtle patterns. So again, in order to make metrics more useful to us, where possible, we should try to correlate them to traces, because then that gives us, again, additional information. And, for example, here, this is an example of metrics that, so for example, the OTel collector has the ability to emit metrics about itself, but also, it emits metrics about your application. We'll get more into the OpenTelemetry collector, but basically, metrics, we can see trends in our data, but what about digging in to understand, hey, what's actually going on here? So like I said, in order to make those metrics more useful, we want to correlate them to our traces. The next thing that I'm going to talk about, as I've alluded to before, is the OpenTelemetry collector. And like I said, the OTel collector, one of my favorite components of OpenTelemetry, it is known as the Swiss Army knife of OpenTelemetry because of all the cool and magical things that it can do. So it is as I said before, it's a vendor-neutral binary, and you can think of it as a data pipeline. It ingests data from multiple sources. It transforms the data. So we are talking about things like we can add and remove attributes. We can apply literal data transformations. We can obfuscate data. So data masking, for example, if you don't want to send PII data, which you never should, the OTel collector facilitates that. And then it allows you to export data to one or more observability backends. Now, the thing is with the collector, so when you're getting started with OpenTelemetry, you could technically, from instrumenting your application, send your telemetry data directly to your observability backend, and that would be perfectly fine. So you might be wondering, well, why then should I bother using the collector? So for a few reasons. First of all, it decouples the source of the telemetry from its destination. So it acts like a proxy. So it basically allows you to essentially ingest data from multiple sources, not just from your application, not just from a single microservice, but multiple microservices, but also from your infrastructure. So you're collecting the data from multiple sources, and then you're applying these common transformations, and then you're spitting it out to one or more destinations. So it's scalable, so it handles changes in volume, and a great example of that is the OTel collector is great for batching your data. So which is useful because you don't necessarily want to bombard your observability backend with a ton of data at once, right? So the batching kind of collects groups of data and then sends that groups of data in little bursts rather than this barrage. So again, that adds to the, that plays into the collector being resilient. And also, you can configure retries, for example, if your backend becomes non-responsive, and then it is secure because you can encrypt data. And again, you can filter and mask sensitive data. And the OTel collector is made up of a number of components. So we have our receivers, and I'll get into each of these shortly. We have our processors, connectors, extensions, and exporters. So basically, as I said, the collector is a data pipeline. So your data flows through the collector by linking together receivers, processors, and exporters to create a pipeline. And fun fact, it's possible to create more than one pipeline. And on top of that, pipelines can be chained together using connectors, and I'll get into what that means shortly. Now, the other thing about the OTel collector is, you might be wondering, that's cool, but how do you configure this thing? Well, we configure it with a YAML file. So this is a sample OTel collector YAML file. So we have configuration for our receivers, our processors, exporters, connectors, extensions, and then we put it all together with our pipelines. So first, let's start with receivers. So as I said, receivers are used to get data into the collector, and we can ingest data from different formats, including Prometheus, StatsD, Jaeger, application telemetry, so OTLP. For example, when your application code emits OpenTelemetry data, that's OTLP format. So obviously, it ingests also data in OTLP format. And receivers can be either push-based, meaning that they can have the information sent to them, or pull-based, which means you have to, like, hey, I'm requesting that information for you, for example, through an API call. And this is a sample receiver configuration. So here we have the OTLP receiver, and you might be looking at that and thinking, well, this thing's blank, so how's that useful to me? So the fact that it's blank means that basically there are some defaults that come as part of these receiver configurations. And so if we leave them blank, that means we're just going with the default configuration. Yeah, that's basically that in a nutshell. So here we're looking at OTLP receiver. We have the gRPC receiver and the HTTP receiver over here. So, all right. So the next component is our processors. And there are a ton of processors in the OTel collector, and they allow us to manipulate data. So, as I said, it allows us to add attributes, filter data, mask data, batch our data to limit our network load, and we can even sample data. So sampling is another important one because, it costs money to send data to observability backends, especially if you're using a SaaS provider, in which case sampling allows you to limit what data you're sending to your backend, but still allows you to send data significant enough so that you can still perform analysis on your backend. So this is what your processor configuration looks like. So here are a couple of examples. So here we have batch processor, and again, we're using the default configuration. And then we also have the filter processor, and the filter processor allows us to do things like dropping spans and span events, metrics, data points, and logs from the collector. So it basically says, hey, if it matches this pattern, we're dropping, and we don't want to include that. And then there's another type of processor that's not listed here, but worth mentioning, which is the transform processor. And this one's a really cool one because it allows us to alter spans, metrics, or logs based on a set of rules. And there's this whole realm that deserves its own overview. So you do this with OTel, or OpenTelemetry transformation language, that provide you basically the syntax and the means to do those data transformations. Next, we have exporters, and those are used to send data from the collector to one or more observability backends at once. So just like we have with the receivers, we can ingest data from multiple sources. Exporters let us send data to multiple destinations at once. This is cool for a couple of different use cases. So for example, one could be, hey, you use like Jaeger for traces, and you use OpenSearch for logs, and you use Prometheus for your metrics. So then you can send different telemetry data types to these different backends, and you would have separate pipelines. You have separate pipelines, and I'll get more into that later, but you have separate pipelines for each telemetry signal. Or you might send send all of your telemetry data to a single backend that allows for the ingest of all the OTel signals. Now, the other cool thing about it is, say you're maybe you're getting started with OTel, you don't have an observability backend in mind, and you're considering a couple of backends that ingest all of the data. So with the collector, you basically, you can send the data to multiple backends at the same time, so that you can compare vendors, compare backends. So you can do like a little bake-off of sorts. And just like we have with our receivers, exporters can also be either push-based or pull-based. So this is an example. We have some exporter examples. So we have the OTLP exporter. So we use that for usually, so that's like sending OTLP native data to a backend that supports OTLP. And fun fact, when OpenTelemetry first started, many observability backends required that you have special exporters that would convert OTLP to that native format. So for example, Jaeger required a Jaeger exporter to send OTLP data to Jaeger so that it could be ingested, and even Prometheus. But nowadays, both Jaeger and Prometheus accept OTLP, so you can just use the OTLP exporter. Here we have the debug exporter, and this one's a super handy one. So the debug exporter, so the OTel collector, when you're running it, it has standard out. If you have the debug exporter enabled, then you can see basically the logs, the OTel collector logs and the standard out, so you can debug stuff if things are going funky. And then this is an example of a Prometheus exporter. And like I said, Prometheus now accepts OTLP data natively, but also if you wanted to use the OTLP, the Prometheus exporter, you can. And then finally, we have connectors. And like I said, connectors are used to link pipelines together. So connectors are kind of interesting because they can serve as both a receiver and an exporter. So for example, there is something called the span metrics connector, where essentially it aggregates, it takes like data about your span. So for example, start time and end time, and creates a metric out of it. So then you can feed that duration, the span duration. So that's the output into of your basically your traces pipeline as an input into your metrics pipeline. So now that span duration that was calculated from the span metrics connector can be fed into your metrics pipeline, which is super cool. And then this is an example of the span metrics connector configuration. Again, we're just taking the default configurations. And then we have extensions. And extensions are a little bit different from the other components that we mentioned because they don't go in a pipeline. So they're not interacting, rather we're not stitching them together. They don't interact with telemetry data, but instead they provide additional collector capabilities. So for example, there's a health check extension used to probe the status of the OTel collector and used as a liveness and readiness probe on Kubernetes if you're running in Kubernetes. There are some other extensions worth mentioning. There's the bearer token extension, DB storage extension, and the HTTP forwarder extension. So this is an example of the health check extension here. And to use an extension, it is included in the services section of your OTel collector config file. And then this leads us to, as you can see in this screenshot, we have as part of the services configuration, there's this other part down here called pipelines. And as I alluded to earlier, pipelines really are used to stitch everything together. So they stitch our receivers, our processors, and our exporters together. And so this is where we define our pipelines. And so it's in the services section in the pipelines configuration. So there are three basic types of pipelines. We have our traces pipeline, we have our metrics pipeline, And again, traces pipeline is used for dealing with our trace data. So you would only have components here that are related to traces. Then we have our metrics pipeline and our logs pipeline. Now you might notice in terms of naming, the pipelines are named traces, metrics, logs, very descriptive names for these things. And if you have one of each type, these are perfect names. But fun fact, you can have multiple trace pipelines, multiple metrics pipelines, multiple logs pipelines, in which case you might be thinking, well, how do I distinguish one from the other? And here's an example pipeline where we actually have 2 different trace pipelines, in which case, so you still need that basic traces, logs, metrics pipeline label in your pipeline definition. But then to distinguish the one pipeline from another, you would put / and then some identifier. So this is an old example from when I was messing around with trace test, and RIP trace test. It was actually a really cool product. But basically this allows us the / and then whatever afterwards. You can call it /blah. You probably want to use a name that's significant to you, meaningful to you, but this gives you an example like, hey, we're having 2 trace pipelines that are coexisting, and basically you would have, and just like you can have multiple types of pipelines, you can have like multiple versions of your exporters. So you could have like, say, or you can have multiple versions of your exporters and your whatchamacallit, your processors and your receivers. And again, you would label them with the / whatever. So basically, and we don't need, like in our OTel collector pipelines definition, you don't need to have like, oh, I need a trace pipeline and a metrics pipeline and a logs pipeline. You don't. You should have at least one of them. So I can have, like in this example, I can have a pipeline that's just metrics and traces, but no logs. I could have a pipeline that's just metrics, or one that's just traces, or one that's just logs. But you should have at least one pipeline of some kind. And then the other thing that's worth noting is we have a pipeline. So again, this is our pipeline example where, as I mentioned, you would have like different pipelines for different purposes. So I want to call out here, first of all, our main traces pipeline is using the span metrics processor and the batch processor, and our traces TT pipeline is using this tail sampling processor and the batch processor. So as you can see, they're not using the same processors. So that's where you would want to use like different pipelines for different purposes, essentially. The other thing worth noting here is that in our processor, when we list out our processors, the order in which you list the processors matters. So for example, because we are, the last thing that we want to do before we send our telemetry data to our backend is to batch our data, we would want to have the batch processor as our last thing. We don't want to have the batch processor as our first thing, because by the time we hit the last processor, it's not batching the data, right? So you've kind of wasted the batching, because it's got to be the last thing you do before you're sending it out to your telemetry backend. The other thing that I wanted to mention before wrapping up is collector distributions. Fun fact, the OTel collector has 2 official distributions. We have core and contrib. Core is basically the bare bones distribution of the OTel collector. So you wouldn't want to use it by itself, because it just kind of has like the base sort of common elements that are required to run like a bare bones collector. Then we also have the contrib distribution, which, so there's actually 2 separate repos in OpenTelemetry for core and contrib. So contrib basically is like core plus additional stuff. So it would include stuff like any exporters that are created by, say, the community that are useful to other folks. So there might be some like AWS specific exporters or some GKE specific exporters, things like that. The Prometheus exporter would be there, but the OTLP exporter would be part of the core distribution. The other interesting thing about collector distributions, fun fact, you can build your own collector distribution, and there's this tool called the OpenTelemetry Collector Builder, or OCB. And basically the OCB allows you to pick and choose the components of the collector that you want to include in your distribution. Now you might be wondering, well, why would I want to do that? And the reason behind that is basically the contrib collector, which I would say a lot of people use when they're deploying an OTel collector. It has a lot of stuff in it. It is bloated. It is a big ass binary because it has everything. It has all the exporters, all the processors, all the receivers. And chances are, when you're defining your OTel collector config and your pipelines, you are using a small subset of all of the collector components that are available to you. So you would want to use the OTel collector builder to basically build a distribution of collector that just picks and chooses the components of the OTel collector that you're actually using. And the reason why you'd want to do that is basically it lessens the, first of all, it reduces bloat, so you end up with a smaller binary. Secondly, it actually uses up less memory. And in this environmentally conscious time of ours, less memory is good, right? Because less memory means we're using up less energy, and that even correlates to cost of your cloud resources. But also it lessens the attack vector, because say you have an OTel collector that has a bunch of extra components that you don't need, and one of the components that you don't need, a vulnerability was discovered against that component. Well, now you're making it easier for attackers to exploit your collector distribution because of that one component. Now, as I say this, I do want to also mention that the collector maintainers are very, very, very conscientious when it comes to ensuring that we have the latest and greatest security patching available for the collector. So, which is why I would always encourage, no matter what, to use the latest and greatest version of the OTel collector, because it ensures that it's got all the latest security vulnerabilities taken care of. So, just important to know. And then there are also, in addition to, collector distributions that you'll out yourself if you wanted to, which you should. There are also collector distributions that are not maintained by OpenTelemetry. So for example, certain vendors might choose to have their own collector distributions. And these include components that they know play nice with their tools. So that's another thing that you can use. Now, in terms of running the OTel collector, you can run it various ways. So locally, using Docker or Docker Compose, you can use it. You can run it in Kubernetes or some other workload orchestrator. I even back in the day, I ran the collector in HashiCorp Nomad, so I know it runs there. Or you can run it as a standalone binary on bare metal. So you can totally do that. And there are a couple of deployment modes for the collector. We have agent mode, which is kind of your common way if you're running OTel collector on your desktop. So it receives telemetry data and sends it to an observability backend. And then we have gateway mode, where basically the telemetry data is sent to a load balancer, and it determines how to distribute the load amongst a pool of collectors. So the nice thing about that is if one of the collectors in the pool fails, then you can just reroute stuff to the other collectors in your pool. So it helps, again, with that, keeps that data flowing, minimizing disruptions. Now, you might be wondering also, well, that's cool, but how many collectors should I be deploying? And the answer is it kind of depends. It really depends on your setup. There are different, there are different approaches to deploying your collectors. I mean, you could have, this is just one example. So for example, if you're deploying collector on Kubernetes, you can run it as a sidecar, in which case it's a sidecar on your application, like in your deployment, in your Kubernetes deployment. So you can run it there. You might want to have like a collector that just ingests like your infrastructure metrics. You might want to have collector that just ingests like your logs, one just for your traces, or maybe like a set of collectors for a set of microservices. And then send all of your telemetry data to like a single central collector gateway that then will send that off to your observability backend. So we have multiple different options for that. Before I continue, I just have a question. How are we doing on time? Are we wrapping up? Because I know we started like 50-ish minutes ago. So how do we have 10 minutes left or more?
I think we can go. I think, yeah, we can still continue.
Okay, because I've got also materials on the OTel operator. If folks want me to continue with that, I am more than happy to continue. I just want to be mindful of the time.
Yeah, after we can also have questions from the audience.
Okay, so
audience can drop the questions in Q&A section.
Am I okay to continue then so far?
Yeah, sure.
Okay, cool. Yeah, just want to make sure. I know it's a lot of information. So next thing I want to talk about is the OpenTelemetry operator. I think it's kind of the unsung hero of OpenTelemetry. So the OTel operator, it's a Kubernetes operator, and it manages, it does like a couple of really cool things. So it is used to manage the OpenTelemetry collector. So it manages the configuration deployment of the OTel collector. And it injects and configures auto instrumentation to your pods. So, when I was talking about zero code / auto instrumentation, this is one of the ways in which you can do that. And to support that, the OTel operator comes with it basically 2 new custom resource types in Kubernetes to support this functionality, and I'll get into that soon. Now, you might be wondering, cool, how do you install the OTel operator? Well, first off, you do need a Kubernetes cluster because it is a Kubernetes operator. And you need to run version 1.23 or higher of the OTel, of Kubernetes. And you can run it, whether it's, a cloud managed Kubernetes, or you can run it locally on Minikube, K0's kind, etc. The other thing that is required for running the OTel operator is it requires either cert manager to be installed on that cluster, or you need to provision your own TLS certificates. Now, we can install, if we're installing the operator and cert manager, you can do so through kubectl or Helm charts. So this is basically if we were using kubectl for installing cert manager and the OTel operator. And then this is what it looks like for if we were using Helm charts. So this is for cert manager, and you need Helm 3.9 or higher. And then this is for installing the OTel operator. So just to give you an idea. And if folks are interested in this deck, I am more than happy to share as well afterwards, because I know this is a lot. Now, as I mentioned, it does manage the deployment and configuration of OTel collectors, and it injects and configures zero code instrumentation into your pods. Now, as part of the collector management collector management capability, it has a custom resource called OpenTelemetry Collector, very aptly named. When deploying a collector managed by the operator, it supports different different deployment modes. So it supports sidecar, deployment, stateful set, and daemon set. So basically, deployment is the default. If you don't specify a deployment mode, it will deploy it as a deployment. So the collector scales up and down depending on the number of replicas specified. Sidecar, basically, it's deployed alongside your application container as a helper container in the same pod. There are special considerations, not special considerations, but the configuration for OTel collector as a sidecar is slightly different from when deploying it through the other modes. Then when we deploy our collector as a daemon set, it basically ensures that all or some nodes run a copy of a pod, and the pod being run in this case is the collector pod. So basically, whenever a node is added to a Kubernetes cluster, then this collector pod is added to it. When the node is removed, then the collector pod is also removed. And also whenever the daemon set is deleted, any pods created by that daemon set are also deleted. Now, daemon sets are handy for per node scraping of the kubelet, and it also guarantees that pods run on every node that matches its selector. And then we have our stateful set, and stateful sets, tend to be associated with being used to persist data in an application. However, they're not just used for volumes. One of the big draws of running the collector as a stateful set is that they do have consistent IDs, because if you run it as a deployment, for example, then your collector pod ID is going to be like, the collector name and then whatever random pod identifier is generated. Whereas if you run it as stateful set, it would be like OTel collector name -0-1 for each replica, which is kind of nice, kind of convenient. Now, they are also different from deployments because they are done as rolling updates. And deploying collector as a stateful set tends to be useful for collecting metrics where you don't end up with this overlap of pods spinning up and tearing down. So you could potentially, like if you're doing it as a deployment, as a pod is spinning up and tearing down, you can end up with metric duplication. Whereas for stateful sets, because you basically you're basically not, you're having to wait for it to spin up and spin down, start up. Spin down, start up. You don't run that risk of that metrics duplication. So now the other cool thing related to this collector management aspect of the OTel operator is this component, little hidden gem called the target allocator. And the target allocator basically allows us to decouple service discovery and metric collection functions of Prometheus so that they can be scaled independently. So what does that mean? Well, it means that, among other things, you can use the collector to manage Prometheus metrics without actually having to install Prometheus. So you can now ingest, we knew that we could already ingest Prometheus metrics from the Prometheus receiver, but now it can even replace a lot of the functionality of having Prometheus installed. So basically, it means that you're having to install less infrastructure in your Kubernetes cluster. And the cool thing about the target allocator is it manages the configuration of the collector's Prometheus receiver for you. Now, back to the two main functions of the target allocator. So it allows us to evenly distribute Prometheus targets. So basically sharding. So Prometheus itself is not great for shard. I mean, it can be configured for sharding, but it doesn't do a great job of evenly distributing those targets, whereas the target allocator does allow you to do that. And the way it works is it first discovers the metrics targets, and then it'll go, hey, what collectors are available? And the collectors will be like, me. Once it does that, then it'll say, okay, these are the metrics targets that are assigned to each collector. So it's like, hey, you collector, you're in charge of these, and you're in this other collector, you're in charge of scraping these metrics. And then the OTel collector goes to the target allocator, because when you're deploying these in Kubernetes, you actually have a separate pod for the target allocator, separate pod for the OTel collector. So the OTel collector goes, hey, target allocator, tell me what I'm supposed to be scraping. And then it goes and then the collector goes and scrapes the metrics. The other functionality of the target allocator is this discovery of Prometheus operator custom resources. So for those who have used Prometheus, there is a Prometheus operator, and it has these two custom resources itself called the pod monitor and the service monitor, and they basically define the so the pod monitor and service monitor themselves do not do any scraping. They define the scrape configurations. They define the scrape configurations for scraping metrics from pods and services in Kubernetes. And in this case, they essentially inform the target allocator or Prometheus to basically add a new job to their scrape configuration. In our case, then, the target allocator then adds the job to the target allocator scrape configuration. And then it goes, okay, now that I've registered these, I'm going to now go and add those jobs to the OTel collector's Prometheus receiver scrape configuration, because ultimately it's the collector that's going to be ingesting those metrics. And the like I said, this by leveraging the target allocator, you can have all of that functionality of ingesting of scraping Prometheus metrics without having Prometheus installed. And so you might be wondering, well, the pod monitor and service monitor, since they're part of the Prometheus operator, how does that work? Turns out you can install the pod monitor and service monitor CRs independently of the Prometheus operator. So that's how that works. Now, all this talk about the OpenTelemetry collector configuration and CR, you might be wondering, what does that look like? So this is a sample OpenTelemetry collector CR. So we have our kind and API version. So this one's v1 beta 1. Kind is OpenTelemetry collector, very, very descriptive name. We have our metadata, and that includes the name OTel call. And then the namespace, I called it OpenTelemetry. You can deploy it wherever. You can deploy it to a namespace called blah. I just deployed it to a namespace called OpenTelemetry. And then this part here in the spec configuration, this is our mode. And as I said, it can be deployment, sidecar, daemon set, stateful set. If you leave it out, it defaults to deployment. And then we have our configuration section, which, if you remember from our OTel collector configuration section, it's the same configuration YAML. So that should look pretty familiar. Now, if you remember, as I said, if you do the OTel collector deployed as a sidecar, in this case, so first of all, in the spec mode, instead of stateful set, it would say sidecar, but also in your deployment YAML, you would have to add an annotation to spec templates, metadata, annotations. So it's the template level annotation, not like our root level metadata annotation. It's got to be at that template level annotation, in which case you add this annotation called sidecar.opentelemetry.io/inject equal to true, in which case then it'll deploy it as a sidecar. And then for anyone curious about a sample target allocator configuration, so in our initial example, there wasn't, I don't think, maybe there was, no, there wasn't a target allocator configuration. In this example, we can see the target allocator configuration. So 2 things. Target allocator is disabled by default, so you have to enable that. And then that Prometheus service discovery functionality, if you want to leverage that, you have to enable that because, again, it's disabled by default. Now, the next thing that I want to cover off quickly is, as I said, OTel operator manages zero-code instrumentation, and it does that by automatically injecting instrumentation into the code running in your Kubernetes pods without touching the code. Yay. And it's done through this, you configure this auto instrumentation through a custom resource called instrumentation. So this is an example of an instrumentation CR custom resource for a Python app. So the kind is instrumentation. The API version is v1 alpha 1. And you might notice here in the spec env section, these are common, these are OTel environment variables. And I have in the QR code here, you can see a complete environment variable list because I never remember these things. But so basically you can configure these environment variables as part of your auto instrumentation configuration. Next, we have this section called exporter. And this is where we define our OTLP endpoint, typically our OTel collector. So in this case, it's localhost 4317. So that means that it is a collector running in our Kubernetes cluster. And port number 4317, I forgot to mention the collector portion, that the collector can ingest OTLP data through either HTTP or gRPC. Port 4317 is the default gRPC port, and port 4318 is the default HTTP port. So just keep that in mind. If we want to configure our propagators, we would do so here. They're different. Remember when I was talking about context, there's actually different propagation standards. So here are some valid values, and you can have one or multiple propagators. And these are the valid values for our propagators. So trace context baggage B3, B3 multi, Jaeger, X-ray, OT trace, and none. And then if you want to define any sampling, you can do so here. And then this one's an interesting one. We have an env section specific to Python. And you might be wondering, well, I have this env section at the top. So why do I have another one? You can think of the top env section as basically like your global environment variables that you want to define. And then this one's like language specific because you could, in a single instrumentation CR, basically say, hey, these are my, if your application's multiple microservices written in different languages, you can say, like, in the same instrumentation CR, I want some environment variable defaults for my Python application, and one for my Java services, and one for my .NET services. And by the way, the languages supported for auto instrumentation, I should have mentioned this earlier. We have .NET, Python, Java, Node.js, Go, Apache HTTPD. This is specific to the auto instrumentation for the operator. For auto instrumentation in general, Apache HTTPD is not part of that because it's not a language. But I believe also another one that's supported by auto instrumentation generally by OpenTelemetry is PHP, but it's, at least last I checked, auto instrumentation for PHP is not supported by the operator. That might have changed since I last played with this. But anyway, so you can have different configuration sections for each language in the same instrumentation CR, or you can have multiple instrumentation CRs for multiple things. So one just for your Python auto instrumentation, one just for your .NET auto instrumentation. So you don't have to dump everything in a single CR. Now, the instrumentation CR, the other thing that's worth noting here is in the exporter definition. So over here we had localhost 4317. That's the default. if you have it set to localhost and you want to send it to a basically to a collector running in your Kubernetes cluster, you do have to specify a proper collector name. So this is your name of the OTel collector. And if your collector resides in a namespace different from your instrumentation CR, then you also have to do the fully qualified name that includes the namespace.svc.cluster.local, and then your port number. And then it's a different consideration for if you're running the collector as a sidecar, then you would use localhost 4317 or 4318. The other thing to note here is, so when you're naming your OTel collector in the collector custom resource, so you might recall when I showed the OTel collector custom resource, it had the name was OTel call. And here we're seeing OTel call -collector, because when your collector is created by the OTel operator, it actually appends the -collector to the name. So when you're referencing the collector name, it's whatever you called it in the collector CR -collector. So keep that in mind. If you don't have that, it'll crap out, it'll fail miserably. Yeah, so that's basically it. And then as I mentioned, this is for if we're doing the sidecar. And then another thing to mention that's super, super, super important to note, the instrumentation CR is the configuration of your auto instrumentation. But we also need to tell the operator, okay, what's being auto-instrumented, and that's where the deployment comes in. Just like we had to add that annotation for sidecars, if we were deploying the OTel collector as a sidecar, we need to add an annotation to our deployment to say, hey, we want to apply the auto-instrumentation to this particular deployment. So it means that you have to have your instrumentation CR configured, and you have to create this annotation. The other thing that's important to note is the order of deployment matters. You can't deploy your deployment and then your instrumentation, because what actually happens behind the scenes is when you deploy your deployment, it'll look through, as it's getting deployed, it'll look through that annotation, and what it'll do is it'll look for the instrumentation CR and create an init container in Kubernetes in your pod to inject the instrumentation into your application container. But if the instrumentation CR is missing, it can't create that because it doesn't exist. So you have to deploy the instrumentation CR before you deploy the deployment. So this is our basic annotation for auto instrumentation. So basically, we have the instrumentation.opentelemetry.io/inject Python. And this says, hey, I'm injecting Python auto instrumentation, and we're setting it to true. Now, you might be wondering, okay, are those my only options? Well, first of all, if we weren't using Python, we're using .NET, you would replace inject Python with inject something else. So inject .NET for .NET, inject Java for Java. You better damn well be sure, though, that your container that you're auto-instrumenting is of that correct language. So if you're doing inject Python, it better be a Python container that you're auto-instrumenting. And then as for other values for that annotation, so yes, we can, so the default is, or the common one is true. You can use false, in which case you disable auto instrumentation for the time being. Instead of true or false, you can put my-instrumentation, where my-instrumentation is the name of your instrumentation resource. So basically it tells, it basically says, hey, I'm looking for an instrumentation resource called my instrumentation in the current namespace. And so the important thing to note here, so if we leave this, if we go with the default value true, it's assuming it's looking for one instrumentation resource in the current namespace, and there can only be one instrumentation resource in the current namespace of our same namespace as our deployment. Because if we have two instrumentation resources in the same namespace as our deployment, it's going to be like, I don't know which one to choose. And then it'll crap out. It won't auto instrument. So if you have multiple instrumentation resources in the same namespace as your deployment, you would specify the instrumentation resource name. If you want to get even fancier, your instrumentation resource can be deployed somewhere else in a different namespace, in which case you have to specify the instrumentation resource's name and the namespace, the namespace / the instrumentation resource name. And make sure that you have your RBAC set up to ensure then that the OTel operator has access to things in the various namespaces, because if it doesn't have access to that namespace, then it won't be able to pull the instrumentation configuration. And then another cool feature as of version 0.86.0 of the operator, you can mix and match, and you can say, hey, I want to inject auto instrumentation in specific containers. So if your pod contains multiple containers, my app 1 and my app 2, you can say, you add this other annotation saying, hey, I want to inject auto instrumentation to just these containers, to my app 1 and my app 2, which is super cool. But then you might be wondering, yeah, but like, what if like I have a pod that has 3 containers, 2 containers have code written in Java, 1 container has code written in Python. Now what? Then you would have your annotation that says, I'm injecting Java into my app and my app 2. And I am so this is my app and my app 2. And then I am injecting Python auto instrumentation into my app 3. So now we can do some fancy mixing and matching. And then before we leave off the operator, I wanted to share some troubleshooting tips when working with the operator, because, I don't know about you, but things never work for me on the first try. So this is from experience, things that I've run into. First of all, make sure that the Cert Manager is installed first if you are choosing to use Cert Manager with the OTel operator, because if it's not up and running and you deploy the OTel operator and there's no Cert Manager, no TLS certificates, the OTel operator will fail to install. Silly thing, but making sure that all your resources have deployed. I've run into issues where I'm like testing stuff out, and I'm like, why is my OTel collector not being deployed? Oops, I forgot to deploy the OTel collector resource. And once you deploy the OTel collector resource, fun fact, when you deploy the OTel collector custom resource, it creates a number of supporting Kubernetes resources. So for example, it'll create OTel collector pods, or in the case of sidecar, it will create an OTel collector sidecar container in your application pod. The OTel collector configuration. So when the OTel collector configuration actually lives as a config map in Kubernetes. So when you deploy an OTel collector custom resource for anything other than sidecar, it'll deploy a pod and also a config map of the OTel collector. Deployment order matters, especially when it comes to that zero code instrumentation. Remember, you have to deploy the instrumentation CR first, because that is our instrumentation configuration. So then your deployment annotation can go, oh, I'm looking for an instrumentation resource that matches these criteria. Otherwise, it can't create that init container. Annotations matter. Remember, if you're going to use collector as a sidecar, or if you're using auto instrumentation, you need those annotations, but they have to be in the right place. It can't be in the root metadata section. It has to be in your spec template metadata section of your deployment. Make sure you check your endpoint configurations. So make sure that they are that they exist and that they're reachable, and that you use the correct one. So sidecar, when you're configuring auto instrumentation with the OTel collector, and you're doing Sidecar, it's got to be localhost 4318 or 4317. But if you're deploying it as non-sidecar, then you need that fully qualified OTel collector name with the port number. And then when in doubt, check the OTel operator logs if you have access to the OTel operator logs, or check for your Kubernetes event. Look for the word error. That's probably the most surefire way to check for errors. And then part 4, I want to talk very briefly about just observability best practices. And I think it's important to call out that the fact that OpenTelemetry enables observability, just because you're using OpenTelemetry doesn't mean that your system is observable. So that's I'd say the main thing. It's like, in the old day, when DevOps was just getting started, it's like, I'm using Jenkins, so I'm doing DevOps. It's like, no, you are using Jenkins. You're not doing DevOps. It's all about the practices. So again, observability is about the practices. Now, when it comes to rolling out observability in an organization, I think there's this tendency, and I have this from personal experience. I worked in an organization where I was managing an observability team. I changed it into an observability practices team, and I'll go more into that. But there's this tendency of like, oh, we're going to stand up an observability team and they'll take care of everything for us. They'll instrument our code and they'll create our dashboards. And like, no. Reliability can't happen without observability. And observability itself has to be looked at holistically. It's not the single responsibility of any one team or individual. So to say like, it's the responsibility of the observability team or the SRE team or blah, blah, blah. No, it really isn't. So what do I mean by that? As I mentioned, we have like the types of instrumentation that I covered earlier. We have our manual instrumentation, zero code instrumentation, and then our zero code instrumentation via the OTel operator. And you might be wondering, well, who instruments that stuff? Well, the developers will be doing the manual instrumentation and the zero code instrumentation because it's their application code. Because if I were to turn to you and say, hey, you instrument my code for me, but I'm the one who wrote the code, that's freaking weird. So developer, instrument your own code. But who also needs to understand stuff like zero code instrumentation? I would say the SREs would have to, because ultimately they're the ones managing, the Kubernetes deployments that are running the containers that have been instrumented with zero code instrumentation, whether it's done at the container level or through the OTel operator. On top of that, talking about managing observability infrastructure, we have collector configuration and deployment, and that involves like managing the deployment and configuration of one or more collectors. But then there's also managing the collector distributions. And you might be thinking, well, okay, then that's probably like your infrastructure people are taking care of that, right? You're right. Like our SREs are probably taking care of like our collector config and deployment, and maybe our CI/CD team is managing the collector builds. But guess what? Developers, I know we're asking a lot of out of our developers, but developers don't need to be experts in this. But if you're going to be instrumenting your code using OpenTelemetry, which you absolutely should, developers are probably going to be deploying a local collector in their environments. And it probably doesn't hurt to build like a collector distribution with just the components that they need. They don't have to be experts at this, but like know enough to be dangerous. Then there's in terms of managing infrastructure, we manage self-hosted tooling, or whether it's self-hosted tooling, in a private cloud or in a public cloud. That is something that your SRE team is responsible for. But then our CI/CD teams also can't escape observability because our pipelines, they might be internal to our organizations, but they are effectively production systems. So if your pipelines aren't observable, if you don't have observability in our pipelines and something breaks, you're like, well, crap, I don't know why that's breaking. And then all of a sudden you don't have that path from like, you're trying to fix a critical bug in prod and you don't have a way to build and deploy your code because your pipeline is broken and you're spending all this time troubleshooting because you don't have the proper observability into it. So, and that brings me to another question, like who does the troubleshooting? And you may have guessed everyone does. And it really boils down to like, developers, they're instrumenting their code as they write it. Well, they're instrumenting their code with OpenTelemetry. You've bothered to go through that, right? Because your SREs ultimately need this information to troubleshoot in prod. Well, use that information to debug your damn code. Similarly, QAs can use that instrumented code to troubleshoot during testing. So, if you're running an exploratory test, the QAs can take that information and go, hey, you know what, developer, I found a bug and here's why, because you instrumented your code. Or they can go back to the developer and say, hey, I found a bug. I can't figure out why, you're missing instrumentation. So then you got that feedback loop. And then SREs, the ultimate benefactors of all this, because when things go caca in production, they're the ones who are leveraging that instrumented data for troubleshooting the application in production. But also, thanks to the instrumentation, SREs need to create SLOs. SLOs, service level objectives, are informed by service level indicators, or SLIs. SLIs are informed by metrics. Where do the metrics come from? Instrumentation. So by having that information, having that instrumentation, they're able to ultimately create those SLOs. But if they don't have those base metrics emitted by the application, they can't do that. But then we run into the problem of like, cool, everyone's doing their own thing, and then we have no oversight. So ultimately, we need to have a unified front on observability, and how do we address it? And we do this with an observability practices team, which is what I did in one of my previous jobs. I was hired into a team where it was an observability team, where we were managing all the observability infrastructure, and the expectation was we're going to instrument people's code and create dashboards. And we're like, no, that's not our purpose. To really make observability work within an organization, the observability practices team is there to put guardrails in place, define organization-wide standards and practices, and standardize on tooling. But they can't exist on an island. You can't just say, hey, you go and do this, developers and QAs and SREs, and I will dictate how to do things. That's up there with like InfoSec defines a bunch of stuff and developers are like, what the hell? That makes no sense. You have to have that collaboration. They can't be the ones to instrument code because, like I said, it's awkward. You're a developer, you wrote the application code, you instrument your damn code. The observability practices team does not do that. And with that, a mouthful. That's all I had for today. It's been a lot, but hopefully you gained something from that. Thank you. Ta-da.
Thank you, Adriana, for this lovely session. As a developer myself,
Avinash, I think you are on mute.
Am I? Oh.
No, I can hear him.
Okay, I think I have a issue from my speaker side.
Okay.
So that was a lot of stuff related to OpenTelemetry, and like I think everyone who joined today got a clear idea, like how the project works, what are the components are involved for which perspective, which part, what they does, right? And we have few questions, I think, in Q&A. First question is from Avinash. Can exporters and receiver be async? Can they receive data by Kafka?
Yeah, they should be able to, yes.
But In the slides, one of the slides, I saw that
Okay.
the only protocols that you
Another one is from Sandeep.
wait.
Sandeep says excellent
Oh, I think
session.
Avinash had a follow-up question. Sorry. I don't know if
Yeah,
you were able to hear him.
I'm not able to hear Avinash.
Oh, that's weird. So the follow-up
Okay.
question to that would be, so do we, in one of the slides I saw that there are only two type of protocols that it supports, which is gRPC and HTTP.
Oh, that's for the OTLP receiver. That's specific to OTLP, but there's like a Kafka. There's like different kinds of receivers. Sorry. Yeah, the slides is meant to just show like a subset of stuff. It's not an exhaustive list. If you want to, let me drop a link here to where you can see all of the exporters and receivers. Okay, so I've dropped a link to the OpenTelemetry collector contrib repo on GitHub, and it has a list of every exporter, receiver, processor, connector.
Sure. We have question from Fernando. Do you have some recommendation of how we can organize all this configuration YAML, a project folder structure or something like that?
I don't have any specific recommendations. I think it's just really up to the team, and I mean, ultimately, like, yeah, I would say it really depends on your team workflow. If you're using the OTel operator, then obviously it has to be in your OpenTelemetry collector YAML. You have to embed that in there. It can't be like, you can't reference an external file. But yeah, it really, I would say, if you look at if you want an example, perhaps I can point you to the OpenTelemetry demo app. I'll send you the link on GitHub. 1 sec. Oops. So here's an example. And I do recommend anyone who wants to get started with OpenTelemetry, check out the OpenTelemetry demo, because it's basically it's a version of the hipster shop, but turned into an Astro shop, because OpenTelemetry. So there's a telescope theme, but it basically features multiple microservices running in written in different languages. There is Kafka running as part of the mix. It's actually gotten really, really fancy since I think it was first launched in 2022, and since 2022 it's gotten, like, there are so many components, it's wild. But it shows basically sending telemetry to Jaeger, traces to Jaeger, logs to OpenSearch, metrics to Prometheus, and then there's some pre-built Grafana dashboards that show you all the data. So it's definitely worth exploring.
I have one question. Like some teams hesitate adopting OTel because like they fear latency and CPU overhead. So what are your stance on this?
So in terms of teams resisting adopting OpenTelemetry, I would say in general, the biggest resistance, I think, is having to instrument your code, right? Because now you're having to go back to your existing code, and you're basically, by adding more code to your existing code, you're introducing technical debt into it, which kind of sucks. And so that can be a huge deterrent. And I think that's why also a lot of organizations are like, well, the observability team will go and instrument the code because developers don't have time for this, right? So there's like so many barriers to prevent, that prevent teams from using OpenTelemetry. And I would say this. So first of all, zero code instrumentation lowers the barrier to entry of instrumentation significantly. So if you're going to start with anything, start with zero code instrumentation, because basically you're adding wrappers. Either you're doing it through the OpenTelemetry operator through instrumentation CR, or the languages that support it have wrappers basically around the language, where you basically call, like, for example, there's the Python auto instrumentation. There's like a binary that you call, and then you pass in like the name of your, literally the name of your Python program. So it injects the auto instrumentation into your code. You are having to do zero work in that, as long as, like in a lot of the libraries in the languages that support auto instrumentation, so have basically, they have they'll emit OpenTelemetry data. So there's that. The other thing is, don't get overwhelmed by stuff that I should have instrumented. Start instrumenting as for anything new, start instrumenting that. It's like, hey, I'm writing a new microservice. Great, let's start instrumenting that. So at least now you're getting to the habit of instrumenting your code. And then finally, I would say, go back to actually two things. One is identify your critical flows in your application. What are specifically in your application? What are the kind of the service flows, the application flows that tend to have, I would say, the most incidents or issues around them. And so rather than trying to instrument your entire microservice, instrument basically the flow. So instrument the components that are most critical. And then finally, I would say instrument your any homegrown libraries or frameworks. Look into instrumenting those, because chances are your code is going to be touching a lot of those homegrown frameworks and libraries. So then that's kind of your final part. So you have to you don't have to solve world hunger right away. We can just tackle it one little bit at a time, kind of thing.
Correct. We have one question from Abhinesh. Can multiple receivers send data to same collector, which does its processing like file log receiver and kubelet state receiver?
Yeah, they can. Yeah. So that's the thing about the that's the cool thing about the collector, is that you can ingest from basically multiple sources at the same time. So yeah, you can definitely do that.
Okay. Two questions from my side. One is we hosted an episode with eBPF, and we are seeing that eBPF gaining traction in observability. So how do you see eBPF complementing or integrating with OpenTelemetry? Do you have any thoughts
I think
on?
it's already there, even because if I'm not mistaken, Go auto instrumentation is thanks to eBPF. So it's definitely a major component.
Okay. And the last one from my side is with the rise of AI ML and LLM pipelines, so what do you think OpenTelemetry's role in monitoring these systems?
I don't have too much experience in that area, but I believe there's a project called OpenTelemetry, which at least I think gives you insight into helps give you that observability of your LLMs, for example. So it might be it's probably worth checking out. Don't quote me verbatim on this, but I know in terms of what it does, but definitely check it out, because I do believe it plays a role in this.
Right. We have one question from Vijendra. Does zero instrumentation provide same visibilities as manual?
So I would never say do either or. Zero code instrumentation is a great way to get started, but it's never you will want to complement your zero code instrumentation with the manual instrumentation, because you might find it's I get this little extra bit, I get like for example, with Python, there's if you do Python instrumentation, auto instrumentation, use Flask, it will instrument basically those service calls. It'll trace those service calls, right? But if you want a little bit more information, you want some more attributes added to that trace, or maybe you want to also add some logs to that trace, then you would definitely need to add the manual instrumentation. I would also say, when you're starting with zero code instrumentation, it's like, it feels like very miraculous. All of a sudden you're getting all this telemetry, but then you might find yourself in a situation where like, crap, I have a lot of telemetry. Fortunately, they're basically flags that you can include to basically say, hey, I want to exclude, auto instrumentation from these libraries, for example. So then it kind of lessens noise if you're getting too much noise on your auto instrumentation. So it's kind of like a double-edged sword.
I also had I saw in a chat that one person, an audience, asked regarding the OTel certification. I also had the same question. Like, do you know, if I want to prepare for an OpenTelemetry certification, which is already there in CNCF certification list. So, any preferred resource that we can choose or we can go with?
I would say for sure the OpenTelemetry docs are a great starting point. And they tend to be the source of truth on OpenTelemetry. And then if you're looking for any supplemental stuff, there's like tons of blog posts and videos out there as well that are complementary to it. But I would say start with the docs. I've written a fair bit on OpenTelemetry as well. So if anyone wants to kind of dig into stuff beyond the docs, I have a blog on Medium, for example, which I'm happy to provide in the comments as well for anyone who's interested.
In the meantime, I have my I think my colleague.
Like, what is the future for OpenTelemetry next years or upcoming years? Like, any features you can share with us, upcoming features?
Ooh, off the top of my head, I don't recall. But I will say this. And by the way, I'm just popping in a link to my OpenTelemetry articles. I will say this. So as I mentioned, I'm part of the OpenTelemetry End User SIG, and we just started a series called What's New in OpenTelemetry, because OpenTelemetry always has like new and improved, it's always like always new stuff coming around, and I can never keep track of it myself. So we had our first What's New in OpenTelemetry last month, I want to say. We're planning one for December. So I would say a great way to stay in touch with the latest and greatest in OpenTelemetry is to check out our video series. And we always, if you follow OTel socials, so we're available, we're on LinkedIn, Mastodon, and Blue Sky. And we also have a YouTube channel. So stay up to date on the OTel socials, because we always post when we run these. And for anyone interested in checking out the OTel YouTube channel, I'm just going to pop it in the link as well. So right here. And we have our first episode of What's New in OTel, which starts to cover off that stuff.
Okay. Yeah, I think Avinish raised a hand. You have a question, Avinish?
Yes. So my question was more of from a dev angle, where let's say if I'm writing a new service and I want to ensure that the telemetry is open. In general, tracing and all those things are a part of my development practices throughout the repo. As a maintainer yourself for OpenTelemetry, what recommendation would you have? Something like, do you need to have a logger that binds OpenTelemetry practices in it, like having something in Zap, Uber Zap, as part of a module itself, which will ensure that tracing is throughout the cycle, or is there any recommendation from OpenTelemetry which
Oh,
will...
you mean in terms of like best practices on instrumentation?
Yeah.
So I would say, so there's some exciting stuff that's come out recently. I don't know if you guys have heard of the company Oligarden, but they have basically, I believe, I want to say it's an open source product that it might not be exactly what you were saying, but maybe a little bit, where their product basically determined the quality of your instrumentation. So then I would say that's a really good starting point, because I think that's a very fair question. It's like, I instrument this stuff. Is it any good? Is it useful, right? So yeah, I would say that that's a starting point. Okay. And it's OLLY Garden.
Yeah. Thank you so much.
Yeah.
Okay, so I don't see any more questions, and so we can wrap it up.
Cool.
Okay, so thank you so much, Adriana, for sharing the ocean of OpenTelemetry. It is quite a lot. I didn't know it had so many things.
So much. Yeah, that's wild. It's wild.
Yeah. I as a developer myself usually go and okay, there are metrics and all those things, that is all fine. So but it had a lot of things that I really enjoyed. In the meantime, while you were giving the session, I was ensuring that I go through the documentation and reading all those things, what all things they had. So I was doing my job.
Amazing.
So thank you so much for your session. And just a reminder to folks, we will have more meetups, more sessions coming up soon. So make sure to join our group and so we have updates over here. Make sure to join our Slack channel and also subscribe to the channel CNCF CNCG Ahmedabad. This is the playlist, and you can find the playlist of this talk as well in future. So yeah, thank you so much.
Thanks so much for having me, and thank you everyone who stuck around. I know there was a lot of stuff to cover.
I'm sure I'm gonna go back to the recording and see the bits I hear and then which I missed again. Okay.
Cool. I will stop the recording. Thanks everyone who joined. Thanks for also you. I hope your questions were answered and you don't have any other doubts regarding to OTel, because I think that all the stuff related to OTel, Adriana answered it well and presented it well. So